Hi, DJ Grace and I did our final project on an efficient and simple breast milk sample preparation to detect polycyclic aromatic hydrocarbons by gas chromatography mass spectrometry by Tamia Durgez and colleagues, published in the Journal of Analytical Chemistry. Breast milk is the main source of nutrients for developing babies, but it often contains harmful substances that are transferred from the mother to the breastfeeding child. In this paper, Tamia Durgez and colleagues are specifically looking for polycyclic aromatic hydrocarbons, PAHs, in breast milk. They are chemicals found in coal, oil, and gasoline composed of groups of 6 carbon rings bound together. Their properties include high lipophilicity, meaning the PAHs can accumulate in the tissue of animals, a high melting point, a low vapor pressure, and very low aqueous solubility. These can be inhaled or ingested by the mother and then passed to the baby through breast milk. This is harmful because they can have carcinogenic, mutagenic, or teratogenic effects. The panel on the contaminants in the food chain has determined that PAH4, a group of 4 polycyclic aromatic hydrocarbons, are the most valuable indicators of PAHs in food.
The main question that the authors of this research wanted to answer is, what is the best sample preparation method of breast milk for quantitative and qualitative determination of PAH levels using gas chromatography mass spectrometry?
In order to find the best way to extract the PAHs from the breast milk, the researchers started by testing 2 different liquid-liquid extraction methods. In the simple extraction method, they first spiked the breast milk to a known PAH concentration, then mixed with a solvent and centrifuged them in an attempt to isolate the PAHs in the upper phase. They did this with 6 different types of solvents. In the complex liquid extraction, they combined the spiked breast milk with the 50-50 mixture of ethanol and water, sonified and centrifuged the mixture, then performed 2 identical hexane extractions. In the third technique, they took the samples that had already undergone complex liquid extraction and tried to further separate the PAHs using 2 different methods of solid phase extraction, the set pack cartridge and the Supel column.
Analytical techniques. After extraction, gas chromatography mass spectrometry is performed. After the PAHs have been extracted from the samples, they use the analytical technique of gas chromatography mass spectrometry. Gas chromatography separates the different components using a capillary column, and then each component elutes based on characteristics like boiling point or polarity. When the components, in this case the PAHs, leave the column, they are ionized and fragmented by the mass spectrometer. In mass spectrometry, the ions are separated based on their mass-charge ratios, and then the peaks are read and the data is interpreted.
After testing each of their methods, they found that for simple liquid-liquid extraction, there was no solvent that produced viable results. For the complex liquid-liquid extraction, they were able to separate most of the PAHs, however, weren't satisfied with just that. In order to improve upon these results, they took the sample that had undergone complex liquid-liquid extraction and then further separated the PAHs using solid phase extraction. They actually compared 2 different methods of solid phase extraction to see which worked better, and found that the Supel column was able to extract 14 out of the 16 PAHs that were in the spiked mixture, better results than any of the other methods.
Here you can see the different PAH compounds that were tested for with each sample preparation method. A check mark means that the PAH was detected using the given preparation method. As you can see on the right-hand column, the Supel MIP SPE column detected 14 out of the 16 tested PAH compounds, making it the best preparation method. Now that they have identified a simple and efficient method to prepare breast milk for PAH testing, they hope to use this method to test real-life samples of breast milk from mothers around the world, and hopefully look for correlations between PAH levels in breast milk and geographic location or lifestyle factors. And lastly, here is an infographic summary of our whole presentation. Thank you guys for listening.